Hello, this is Brian Raya with sprint number 2 for Engine 2. I'll briefly start off just showing a demo. So this is my soldier. This is him with the bounding box. As you can see, as I rotate, the box morphs to fit every single one of the points. Again, no interest in rotation. We will move and I will collide with this. As you can see, the frigate turns red. The soldier does not, because the soldier is also registered to collide with the tank. So as you can see, this point is touching. I will move back, and as soon as I collide with the tank, I'm registered to quote-unquote enter the tank and manipulate that. I can exit. Once again, colliding with the frigate turns red at the very bottom, as you can see. Colliding with the tank allows me to enter once again. Going briefly into the code, we have our collision volume ABB. We maintain our minimum and maximum point. On compute data, we make sure that we go through our vector list, and we end up getting our minimum and maximum points through that. And at the very end, we just store those values. Our visualizer basically takes our minimum and our maximum. Our size is our maximum minus our minimum. Our position is half of adding our minimum and maximum. And after that, we have our world matrix for our cube. We add that onto our visualizer list, and after all of our spheres have been rendered to the screen, we worry about our boxes. I do plan on messing with the visualizer a bit more later on, because I don't like the fact that if I'm registered to 2 collisions, because the second one registers as not colliding, even if I am colliding with a object, the color still remains blue, as you saw with the soldier and the frigate, but that's a problem for later. The math tools that I used in order to help me out is I created this clamp function. This is for the AABB with a B sphere, and I needed that clamp for again, this test. We got our sphere center, we have our minimum and our maximum, and we clamped the sphere center to that point. And at the very end, we run basically the same information as we did with our B sphere to B sphere test. We basically just make sure if our current distance from that clamp point and our center point is less or is greater than our radius, and that will determine if we are inside or outside our collision zone. Our OBB is ready for next week's assignment. I've gone through the tools, and that should mainly cover everything for this week. I have not been working on my research project. I should move on with that, and I should start working on some demos, and hopefully next week I'll have something to demonstrate or prototype for Sprint 3. Other than that, that covers collision. Thank you very much, and goodbye.